What's up, guys? In this video, I wanted to show you guys a pattern I made or a pattern I implemented for a coding challenge that I did for this firm called Saturn. Saturn is a social networking app. It's targeted towards students, and it lets you create schedules and share them with friends. And I got a challenge to design a notes app that will sync offline and upload notes to a API. And I'm going to talk about this pattern of reactive using signals. If you're familiar with iOS engineering, you already know that there's no like built-in reactive model. Everything is kind of polling. So one way to get around this is creating a thing called a signal. A signal is a concept that it's basically a protocol that implements a couple functions. It has a list of listeners, which are callbacks to every object that's listening to the signal. It can fire, it can subscribe, and it can unsubscribe. And in Swift, you can type alias it as a signal, and any object can become a signal. You just has to implement just has to subclass off of signal base, which implements the bare bones of all the functions, and then it also inherits from this st signal protocol. So to illustrate this, I'm going to show you guys what it means to build this kind of system. So if you already know, in iOS, a lot of times you're referencing off a couple data tables, a couple models. For example, if you do something like an NS, a UI table view, you know that the UI table view has a delegate and has a data source. So the data source will actually be able to grab a lot of rows, and then every row is a UITableViewCell. So to build a UITableViewCell, you have a subview, and then you also have to format it with some sort of data model. So there's a couple ways to do this. You can refresh and check it programmatically, where when the database gets updated, then you can let the table view cell know, and then tell it to reload tables, reload the data, or you can tell it to update rows or update sections. Now, what I'm proposing is another way of doing this, and instead of telling the UI table view, you can directly link to the UI table view cell. And basically every time it gets updated, you can actually tell it to fire, and it will reformat itself based on the actual data that's coming in. So this will send an object which contains the data in the data model. So how to implement this? We're using signal base. So we have data models we have a lot of data models in the database. Which all derive from a base signal here. which the base signal conforms to a protocol here, ST signal. ST is just a prefix. It can just be signal. It's a prefix because I called it Saturn test, but it could actually be anything since my initials are JB signal. So JB signal is inherited by base signal, which is then inherited by the data models. That would give every data model the functions fire, subscribe, unsubscribe, and a property is called listener. And listeners is an array of signal callbacks. So basically every time you call fire, it'll go through every signal callback in the listeners and then just tell whatever listener that's registered as a callback to update it with the new object. And this is called every time you run fire. Okay, so that's the pattern. Let's see how it's implemented. And if you're still watching this video, I encourage you to like and subscribe. This tells me that I'm doing a good job and you want more videos like this. I cover iOS engineering, I cover interview prep, system design, also backend engineering. I have a couple apps on the App Store as well as released a couple products. And check the description. I'll include a link to the GitHub for the signal code to implement it yourself, or you can use the signal code to bring it into your own project. Check the description. I'll include the link down there. So signal base, ST signal over here, is the base signal, the protocol, which is the fire. The fire, the subscribe, and the unsubscribe in this case is returning an index of it, because just for time's sake, it's not extremely robust, but later on what you could do is you could instead have a callback as an unsubscribe, and then check the listeners for the signal callbacks. But that's not the best way because optimizations could move it around. For now, this is completely safe, and it is. There are probably better ways of doing this. This is the MVP of the signals. Signal base, which implements the base protocol, and then also implements the base functions. So every object after this inherits it. The fire goes through every listener and sends the signal of itself. The subscribe right now is subscribing to a listener of 1, but you can change this to listeners.append the callback. But for now, this is to keep it simple. And then here, these are the objects. So you can see here, the note manager, which holds all the notes, is holding a signal. Is deriving from signal base, so we don't have to implement those functions. And then it contains all the data objects. And then we set up a couple times that we fire, such as when we append a note and when we move a note. This just tells every listener that's listening to this that we have updated the object and you should probably update your data. In the note, we also derive from signal base, and we see a bunch of properties. So for the Cocoa pods in this project, we're using a couple pods. We're using SnapKit, Alamo Fire, reachability, Swift, SD web image, and realm Swift. And in this case, we're going to be using realm to store the database, and this is a way of storing it into a realm database. It's similar to core data, and we're deriving from signal base, so this object will automatically be registerable, and and other objects are able to listen to it. Another way we can create this to allow for public interfaces and updating the signal base every time a variable is updated is adding something like a var public interface with a get and set method. So set small URL to small photo URL, and then every time we set it, we'll actually call fire to let whatever listener is listening to this know that we have updated the contents of this object. So that would be another way of doing this. In this case, just for time's sake, I left it as bare bones as possible, but you can really do some cool things to make this a lot more robust. And to show you this in action, we can actually go into the preview controller, and we can see in the view up here that we can subscribe. One thing that is very important is to make sure you unsubscribe. And you can do this in the view did disappear function, and make sure you unsubscribe from all these notes, because the way that Cocoa garbage collection works is if a function another object holds a pointer to a function, it won't fully be released. And that means that you could run into potential memory leaks, which will make your application slower if it runs over a long time. So make sure you unsubscribe from these methods. That is a very important point, because if you don't unsubscribe, then the garbage collector in Xcode and LLVM garbage collector will never fully deallocate your file. So if you open up a bunch of files, basically you'll have like a bunch of floating objects that over time will slow down your programs. It becomes sort of like this, where it's just like everything is just floating around, but you can't really do anything about it because you don't know where the pointers are. So make sure you clear the object at some point. You don't want those cyclical dependencies, and that will slow down your program in the long run. So make sure you unsubscribe, and you can do that just by passing in the index of the object. And you're actually getting the index inside the subscribe pair that gets passed back as the first element, and then the object as the 0th element. So you can call, if you save this as a property in your code, you can actually call an unsubscribe like this. And this will unsubscribe it every time your view did disappear. Make sure you do this, is very important. And then also in the table view cell, which is a lot more interesting, we actually can call it every time we run configure. Configure will start listening, and we're actually just unsubscribing if it already had a listener, and that's okay. And then we run subscribe and run an update based on the note data. So over here, this is a configuration code. Notice we don't actually put in the configure function. We put it as a callback to the signal pair. This will make sure that you every time the signal gets updated, we'll reconfigure our cell. And you can see there's a couple states: when it's pending, when it's in progress, when the photo ID doesn't exist, and otherwise the general case. So let's run this program and sort of see the updates in person. So you can see here we have a list of all of our notes. This is cached using Realm. So we're gonna upload something here, test upload, and first we're gonna check the configure, and then we're also gonna check the note upload subscription. So we're gonna run this. So you can see here, first we upload the new OBJ. And we can see at the very top, then we have our new note that's pending. And this is the same note that was pending. Now it's in progress uploading wise. So now it's uploading, and then if we set another breakpoint, it will update us again when it is done uploading. So now it's still pending because it's still in the progress. And now it's successfully uploaded with our caption test upload, which is our most recent one. And you can see here that it updates the data altogether, and this is never calling table. This is never really calling table reload. It only calls table reload when the actual table is updated over here. Otherwise, all the data is being updated within the signal, within the actual TableViewCell. So this is a really good use case of the signals, because if we take table upload, reload completely out, we can see that it gets updated even then. So this is a good use case of signals, and it's a great way to make your program a lot more robust, because you aren't constantly pulling and re-updating data, and it creates a way of two-way data binding. So if you watch this long, make sure you like and subscribe this video, check out the code in the description below, and thank you again for watching.